Welcome back to the Commodore room. In our last video we took this 1541 disk drive and replaced the power supply and reworked a lot of the power circuitry in order to save some weight. If you've seen that video, you'll know that we saved nearly 3 pounds of weight when we did these modifications. If you haven't seen the video, certainly recommend you go back and check it out and let me know what you think. When we ended the video, we had one thing that we really didn't quite finish, and that is the power LED. So let me show you what ideas I had around this LED and what to do with it. When we were working on this disk drive last time, I noticed something on the circuit board that I want to call your attention to, and that is this chip right here. This looks to me like an EEPROM. For those that don't know, the difference between a ROM and an EEPROM is really pretty simple. A ROM is a read-only memory chip, which is essentially, you can think of it as a cartridge in a video game, or it's like a book. Once it's written, and there's really no way to change it. An EEPROM, however, is a bit different. An EEPROM stands for Erasable Programmable Read-Only Memory. So underneath this sticker, there is a window, and if that window is exposed to ultraviolet light, you can erase this and then reprogram it using an EEPROM programmer. As we talked about, the 1541 was notoriously slow. There was a lot of different fast load cartridges available, lots of software included their own fast loaders, and there were also some hardware modifications, such as replacing these ROMs, that were available from a variety of manufacturers. One of my favorites is JiffyDOS. JiffyDOS required an installation in the computer itself and then in the disk drive, essentially replacing the DOS ROMs and allowing the disk drive to go significantly faster. What we're going to do is we're going to replace this with a JiffyDOS ROM. The downside to JiffyDOS and a lot of the fast loaders available for the Commodore was that some of the software wouldn't support it. Because the 1541 was so notoriously slow, a lot of software included their own fast loaders. And those fast loaders oftentimes conflicted with hardware modifications or some of the cartridge accelerators. So JiffyDOS typically comes with a switch to allow you to turn it on and off. So this is the JiffyDOS setup, essentially. Now this one is for the 64 itself, but essentially it's the same for the disk drive. You have the ROM, and then you have a switch to enable or disable the ROM. So basically what happens is, inside the ROM chip itself, you have the original copy of the Commodore code, and then you have the JiffyDOS version of the code. The switch allows you to go back and forth between the two. I find this type of switch to be aesthetically unpleasing. I don't like the way they look. It protrudes from the case. It's just sort of obnoxious. I mean, in a way, it's kind of cool, and I've used these switches plenty of times. But I really prefer something a little bit better. I like the little push-button switches. They're more sleek. They fit into the case a little bit nicer. I just think, personally, that's a better way to go. So what we're going to do today is we are going to put the appropriate ROM into the 1541, and we're going to wire up a different type of switch. I know what you're thinking, well, what does that have to do with the LED? I'm going to show you that here in just a second. So what we're going to do is put JiffyDOS in this 1541. And we're going to use a push button instead of this toggle switch here. Now the challenge, of course, is you cannot look at a push button and easily tell whether the switch is up or down or engaged or disengaged. So we're going to use the LED for that. We're going to put a multicolor LED in that changes colors based on the position of the switch, whether it's in or out. So coming over to my parts bin, we're going to look and see what type of switches we have available. And I've got a lot of different ones, but I really want to find a switch that looks cool. So here we go. What I've got here are a bag of switches that I found probably on Amazon or AliExpress or someplace. And so I'm going to pick a switch that I think would look neat. Certainly not going to pick that one. But let's go with... So we're going to use this switch. We're going to mount it on the front of the disk drive so it's easy to see, easy to change the modes from JiffyDOS to normal DOS. And then we'll hook up a multicolor LED to allow us to know visually by just glancing at the drive which ROM is enabled. So going back to my parts bin, I need to find a good multicolor LED that we can use for this project. So there are a variety of ones. This is a blinking LED, which would be really fun, but super annoying after just probably 20 seconds. This is a full color LED, obviously a Radio Shack part, 5mm LED, so it will fit nicely into the case and won't be too much trouble to wire up. Now looking at the specs on this LED, we can see there's a couple interesting things. The supply voltage varies a little bit. The maximum supply voltage does vary a bit depending on the colors that you're using. And there are some differences in max current depending on the colors that you're using. So using red looks like to be the difference. Blue and green seem to be the ones that use the same limits. So what we'll do, just for the sake of simplicity at this point, and to reduce the part count, is we're going to use blue and green. So we'll use, let's say we'll use green for normal Commodore DOS and we'll use blue for JiffyDOS. That seems to be kind of fun, and you don't see a lot of blue LEDs on Commodore, so that'll be kind of fun. So what we'll use in order to transform the on or off position of the switch into different pins is we'll use a demultiplexer or a decoder. So a 74LS138, which is a fairly common logic chip, we'll use that, and essentially what that will allow us to do is turn this switch into the appropriate signals to fire this LED off. So here's the schematic I came up with. When the switch is closed, essentially a 0 will go to A0 on the 138, and when it's open, essentially 5 volts goes to A0. So we're basically sending a 1 or a 0 into this. If you look at the data sheet for the 138, you'll see that these lines need to be pulled down to ground, and a couple lines need to be pulled up to VCC or 5 volts in order to get what we want out of it. Essentially, this decoder or demultiplexer takes a binary coded number in and basically fires or brings high individual lines based on the input. So if a 1 comes in, a binary 1 comes in, one output will be high. If a binary 3 comes in, a different output will be high. And keep in mind that a binary 3 is a 1, 1, and it really just brings one pin up to high based on whichever ones are high on the input side. So it does exactly what we want, which is why we're using it here. These two resistors on the right, R2 and R3, are basically configured as a voltage divider with the values selected correctly so that we can keep the current under control to the multicolor or tricolor LED and also have the appropriate voltages so we don't blow it up. And then finally, pulling off of the appropriate pin from the 138, we can control the essentially which 8K bank of that EEPROM is enabled. So that's basically the circuit that we're going to build. So here's the prototype of what we're going to build and put in the 1541. So essentially what we have is that toggle switch, the single pole, single throw push button toggle switch, and the LED. So let me go ahead and turn on our power supply. This is not hooked up to the 64 yet, or the 1541 yet. This is just hooked up to a power supply on my bench. The idea is to take this single pole, single throw push button toggle switch and change this LED to either be blue or green depending on whether the button is open or closed. But basically pushing this button changes it from blue to green. As we saw earlier, there was an EEPROM adapter on this board to allow an EEPROM to work in a ROM socket. I'm going to go ahead and build a new adapter to use on this project. I kind of like the way this one is laid out, and I'm going to set it aside for maybe some future projects. So I'm going to build an adapter to allow this 28-pin EEPROM to fit into a 24-pin ROM socket. I'll put the link below to the instructions on the internet on how to do this in case anyone wants to do it themselves. And there we go. That should do it. The easier way is to go buy one. There's these adapters are on the internet, easy to find, or you can make one yourself. Burning the EEPROM is fairly straightforward. Fire up Mini Pro, double check, make sure that my EEPROM is actually empty.
Then also make sure that we've got the right device selected or the right type of EEPROM, which we do. Next, I'll go and find the file that I created that has both the JiffyDOS and Commodore ROM, and then basically just program. It's important to note that while JiffyDOS is all over the internet, it is not free, so I always make sure that when I burn one, I go and I buy a copy from the website that I'll put down in the description below. So, programming is done. We can verify. It does it automatically, but I like to do it twice. And there we go. We have an EEPROM that we can use in our 1541.
So this is the real estate I'm going to use to put that circuit board with the 138 that is going to drive the LED and the button. So what we'll do is we'll mount that board there. We've got some convenient holes left from the voltage regulators. So we'll make a very small board. We'll put it here. We got power very, very close. We can make a connector, drape that over down along the side, and put the push button right down here. Actually, no, that's where the LED is going to go. We'll put the push button down over here. So we'll have a button kind of conveniently placed, maybe a little high, so you can switch back and forth and the LED will change colors.
So the next step is to assemble the circuit. I've got this small piece of perforated circuit board, and I'm going to get all the components mounted on it. I've drilled a couple holes in it to match the hole pattern where the voltage regulators were on the 1541 motherboard, so I can use plastic standoffs and screws to attach it. On the board itself, I'm going to use DuPont style connectors sort of at a, I guess you would call it a right angle or parallel to the board. That way they don't stick up too high. And then I can connect the power source, the momentary switch, and then of course the multicolor LED. Once I'm all done, we'll test it out before permanently mounting it in the 1541 just to make sure everything operates as we expect it to.
Okay, here we have the circuit board complete. Everything is soldered together and everything looks good. So I went ahead and I jumpered that into the 1541 along with the switch and everything else. And so we'll go ahead and power it up. And we have a nice blue light. And we push the button. We have a nice green light. So everything looks good. I went ahead and I checked the bank selector, the wire that goes from the decoder to the EEPROM to make sure we're selecting the right 8K bank. That all looks good. So our circuit board is done. The only thing left to do is to mount it, build the connectors that go from the LED to the board and from the switch to the board along with the power connector, and then that bank selector wire, which I went ahead and just put a wire on it and we'll just solder it on to the EEPROM adapter that I made there. I think that's probably the easiest way to do it. Might put a disconnect on it. We'll see how I feel when I get to that point.
The next thing we need to do is drill a hole in the case so that we can mount the push button switch. It's going to be a bit of a tight fit because of the support that you can see right behind where I'm going to put the button, but I think we'll be able to make it work. I may touch it a little bit with the drill bit, and as you'll see here, I will touch it a little bit with the drill bit, but it's good enough and it does work. So I find these drill bits are the best way to drill plastic, so if you're trying to drill plastic using a traditional like wood type bit, you're probably going to have some problems, especially if you're trying to drill bigger holes.
I went ahead and mounted the circuit board that we designed and built using the plastic standoffs and the plastic screws, as you can see here. Doesn't ride too high from the board. We've got our yellow wire, which goes to the ROM, so it's basically our bank select. Then the first connector here is for the switch, or I'm sorry, for the LED, then the switch, and then power. And that's it. So we power on the drive, we have the green light. Green light should indicate Commodore DOS. So let's zoom in and we can see that it's Commodore DOS. Okay. Now let's push the button. Light changes the blue. Turn everything back on so it reinitializes. And we have JiffyDOS. Now, as I mentioned earlier, sometimes you can do that switch while the machine's running and it will go faster or slower. And then sometimes that will cause the drive to crash. Nonetheless, everything looks good here. So let's go ahead, put the case back together. We'll run a couple tests and wrap it up.
Just real quick before we button everything up here, let's take a quick tour. Here is our ROM select button, allows us to switch between JiffyDOS and Commodore DOS. Here's our multicolor LED, which will be green when it's operating normally, and then blue during JiffyDOS. And then finally, here's the circuit that we designed and built to control all of that functionality. And there we have it, a Commodore 1541 disk drive with a ROM selector switch on the front to allow you to select from 2 different ROM images. Doesn't have to be JiffyDOS, could be anything that you want. And then also a color indicator to let you know which of those ROM images is selected. If you like this video, we would appreciate it if you gave us a thumbs up. If this is the type of content that you're interested in, please feel free to subscribe. And thanks for watching the video. I hope you'll come hang out with us in the Commodore room again real soon.